IoT Unplugged. Tune in to the Internet of Things. In the rapidly evolving landscape of IoT, deployment strategies have emerged as a cornerstone for achieving operational efficiency and maximizing the value of IoT implementations. Successful IoT device deployment hinges on a comprehensive approach that includes meticulous planning, selection of the appropriate technology stack, and integration into existing systems. Critical considerations must include scalability, to ensure the infrastructure can grow with demand, security, to protect data and devices from cyber threats, and interoperability, to facilitate seamless communication between diverse devices and systems. Moreover, energy efficiency remains paramount for battery-operated devices, necessitating the deployment of power-saving technologies and algorithms, and maybe even future considerations for energy harvesting. Yet, as organizations navigate these complex considerations, the question arises: how can businesses best leverage IoT deployment strategies to not only meet today's requirements, but also anticipate future technological advancements and market and regulatory demands? To discuss this further, I'm joined by Deepal Mehta, Senior Marketing and Business Development at InnoPhase IoT. Deepal, thank you for joining us. Could you start by introducing yourself and sharing a bit about what InnoPhase IoT does?
Sure. Thanks, Christine. Thanks for having us here. So I'm Senior Director of Marketing and Business Development at InnoPhase IoT. I joined them early last year from Intel, where I had spent 20 plus years in the various business roles, from wireless UWB to networking and other business units. So InnoPhase IoT is a privately held company which is focused on ultra low power Wi-Fi BLE. That's been the laser focus of the company. It's developed a unique proprietary polar digital radio technology, which gives tremendously low power compared to other solutions out there, while still being compliant to the Wi-Fi BLE 6 standards. Developed 100 plus patents around this, and the first instantiation of it is a grounds up SoC built for IoT market for low power battery operated devices with an integrated MCU, Wi-Fi, and BLE solution all into one. We are a worldwide organizations with about 120 plus people, with teams in San Jose, which is our headquarters, San Diego. We have a team in India, about 45, 50 people, and then teams in Sweden and China. So pretty wide worldwide team. We do chips, which is like, so we are a fabless semiconductor, building our chips at TSMC. And then we build modules, Wi-Fi and BLE modules to enable quick time to market, which are all regulatory certified. And on top of that, we build software solutions with silicon partners to come up with a total device solution that can enable customers to have quick time to market for IoT segments. So very focused on IoT, very focused on smart home, industrial IoT, commercial buildings, medical, your typical IoT use cases. And we've been there for more than 10 plus years, have products in production since 2020, and looking forward to working with customers to grow the industrial 4.0 revolution in a sustainable manner through our low power technology.
Okay. All right. Well, you mentioned a lot of sectors where you're working with IoT within, and I wanted to explore the deeper aspects of these IoT rollouts that you're involved in. I was wondering, could you describe what an effective IoT device strategy looks like and why it's essential and what key elements it should consider?
Right. No, so as you know, IoT device architecture is a pretty complex subsystem from a name of IoT, which is Internet of Things. So you need to be connected to the internet. So you need a cloud connectivity solution where you can connect to AWS, Azure, or other public or private clouds. since you are an IoT device. So although we do Wi-Fi BLE connectivity solution, we pair with silicon MCU partners or image processing chip partners like Ingenic, Umbrella, Omnivision. Or on the MCU side, you have to partner with companies like ST Micro, Novoton to have a integrated hardware software device solution, right? That the customers can take on. There's intricacy of Linux-based hosts or a real-time operating system-based host talking to us, who are a RTOS-based system, drivers interface, hardware, interfaces, connectivity to sensors. So complete reference design solutions are required with silicon partners and a complete software system. So that would be the starting point. And then you need to make sure that not only it's functional, but it's very low power. So not only the individual components have to be low power, but then working as a device, you have to think about power all the way from sensor to cloud. How can I operate with lowest power and extended battery life? That involves, okay, maybe offloading the cloud connectivity piece to the Wi-Fi solution, sensor interface to the MCU, and then making sure the devices are shut off when they're not used. So pretty complex software integration between the two devices is required to manage the power. You have to think about interoperability. So, as you know, there are various wireless solutions, but we focused on Wi-Fi, which is predominant technology. 50% of the smart home devices would be based on Wi-Fi. So we want to make sure consumers of the IoT devices can interoperate with access points in their home or in their enterprise without having to go through any intermediate hub. So that would be a consideration. The other thing is performance, which is always key for any computing device. You want to make sure, even if you have lower power, you don't compromise on the performance, specifically with IoT devices where you're capturing images, you're capturing video, and sending it to the cloud. Performance is very important, especially in noisy environment, because you don't have a clean environment in real world. So you need to have techniques to take care of that. I mentioned certification earlier. Since you have to ship globally, worldwide, you need to make sure you have all the certifications from FCC, TELEC, and other global regulatory bodies so that you can ship the device. And you want to make sure from a ease of use and operational cost also, you have easy to provision the Wi-Fi device. You have easy capability to upgrade the software. As you know, IoT devices need to be managed from the cloud. You'll have new AI models on it. You'll have new firmware updates. So you need to do it seamlessly from the cloud. So those are some of the considerations in terms of the system design, the software, the management of the device. And then all this needs to be paired with a good ecosystem, right? Where you have silicon partners, you have software partners, you have services, IoT services partners, all available, design partners available to the OEMs to customize the solution to their need, to enable quick time to market. Now, all the complexities I mentioned was the reason why it used to take 18 to 24 months. Now, with a very focused approach, doing partnership early on, having a design partner ecosystem, having the hardware software integration done with also support of ODMs and contract manufacturers who have done the solutions before for other customers, you can get 6 to 9 months time to market kind of a possibility, right? And that's what we have worked on. So a rollout of IoT device is very complex, but if you work with the right partner, with the right considerations early on, you can avoid the hurdles and get to market in 6 to 9 months from start. So that those are some of the considerations to think about as an OEM when you're trying to roll out an IoT device, IoT service for the end customer.
Okay, and also speaking about rollouts, what impact do extreme low power wireless solutions have on the operational lifespan and efficiency of IoT devices, especially in larger deployments?
Right. So, what I talked about was just getting the device out to the market, right? A consumer or a commercial enterprise buys this IoT devices, deploys it, but that's not the end of it, right? A lot of these devices are wireless devices, untethered devices, right? So they're battery operated, and the batteries don't last forever, right? So if you look at, and that was one of the hurdles for the IoT market, is the batteries need to change too often. Sometimes you see cameras where the battery will run out in 3 to 6 months. So you can say, okay, I can change the battery of a camera. But if you look at the real home, there are a lot of devices. We have a customer that has wireless operated blinds. You might know, actually, I'm remodeling my home and trying to get new blinds. And there are so many blinds in the home. Each one will have a motor that can be controlled wirelessly through the remote and through the cloud. Think of the amount of batteries that are there just in the blinds. Then I would have other devices in the home, like appliances. You would have thermostats. You would have smoke alarms. So and this is just the home. If you go to the enterprise, you'll have a factor more. And if you have to change all these batteries so often, that becomes a full-time job. So we want to extend the battery life, have low power focus, so that the operationally it's feasible, right? Otherwise, people give up and say, "Hey, I don't want to use this device or service. Maybe I just do things manually my own way," right? Like you operate the smoke alarm or the blinds and appliances more manually rather than wirelessly. So the low power has been very critical from a ease of use, operationally, as you're saying. Now there are certain use cases where long battery life is in fact a requirement more than just ease of use, right? So we have a customer who has planks for hardwood floors, and they're putting some sensors below that for measuring humidity, pressure, who is at blame when there's some insurance claim. That has to be 7 years minimum, because you can't just remove your hardwood floor and change the battery below it. So there are cases where, or if you are an asset tag kind of a device, right? You're trying to make sure the location can be serviced. You don't want to run out of battery, because then you miss the location, right? And you can't even know where the device is to replace the battery. So certain devices need a significant long 5 years, 7 years, 10 years, and that's what the power battery operated device solution is very key. So hopefully that gives you some of the perspective of the challenges in terms of dealing operationally with the battery operated devices.
Okay. Well, you talked about low power devices helping deployments because it eliminates one of the challenges of constantly having to replace batteries or so on. But I was wondering, what other technical challenges are there for scaling IoT devices, and how can companies overcome these to ensure a successful deployment?
Right, right. So we talked about, once the device is installed, the battery management is a problem that we address. The other technological challenges, as you know, there's significant technology disruptions happening in this market at an amazing pace, right? So you heard about AI coming into fore throughout all sectors and throughout all services. We see AI coming in the IoT space also, where you need to do predictive maintenance, inference solutions right at the sensor edge. For that, you need to deploy AI models, you need to keep on updating it. So scalability of the solutions, once it's deployed, it's good to get started, but then the needs of the consumer, the needs of technology would need the platform to be scalable. The other situation we are seeing is, okay, you have a Wi-Fi device, as I said, you can manage the blinds, but now there is a move towards Matter protocol, which runs over Wi-Fi, which allows you to interoperate with other Wi-Fi devices in different ecosystems. So maybe I bought a device which talks to my Alexa, Echo, or Google Home device, but then I want to upgrade my device with Matter protocol so that it can operate with Apple, it can operate with Google, Amazon, Samsung, anybody else that may come along. So you want your device to be scalable. You want to update the firmware wirelessly through the cloud very easily, so that you can get advantage of these new technologies. There's AI in various forms in terms of predictive maintenance. You want to be able to talk to the device. All this is scalable if you have architected your base platform correctly, right? And that's what we look to, working with customers, working with partners to make sure the platform architecture is scalable. That would take care of these devices through their life, right? As they look at 5, 10 years of life of this device.
Okay. Now, moving on to some other considerations. Obviously, security is a big issue with, or a big concern regarding IoT devices and systems. How can security be balanced in devices that are low power? And can you offer insights into how businesses can design their systems to be secure?
Right, right. So, as you rightly said, security is very important. In the past, there have been cases where people have got into the networks through an IoT device, which nobody thought about security in the beginning, like a camera device, and then they get through in it, and they're inside your home or inside your enterprise. So, security is one of the key features or requirements, I would say, for IoT device. So, and there are security at different levels, right? One is what we call protecting the device, so that people cannot tamper the firmware in the device, right? Once they can tamper and get control of the firmware, then pretty much they own the device. They can change the operation of the device. So we implement technologies like secure boot, which make sure it will boot the device only if the firmware image is not tampered, right? So that's kind of built into the device. So no matter where it's deployed, it can catch things being tampered through the supply chain or through the deployment. The other thing is, you want to connect to the cloud and transfer data. You want to do it in a more secured way, right? So nobody can sniff that or nobody can modify it. And so for that, you need to encrypt the data at the device and then send it to the cloud. Or if you're getting a cloud communication, then you would be able to decrypt it and use it. So all the firmware transfers that downloads happen, or even data transfers that happen from the sensor data to the cloud, they're all encrypted. You want to do that in a hardware way. So we have built-in hardware engines that do the encryption for low latency, secured transmission. And then, as part of the security, you need to have secure keys. You want to make sure those keys are protected. So there are mechanisms in the SoC and the chips where you can save the keys securely, right? And so there are technologies like Puff and other technologies we've developed that would enable the keys to be secured also. So security has to be just like battery life and performance. Security is another pillar that you have to take it very seriously. There are PSA level 2, PSA level 3, different security levels, and depending on the device and where it's going to be deployed, we need to make sure the device would be secure to that level, right, and certified to that level. So it's a mix of thinking from day one with the hardware elements and the software elements to make sure the device is secure.
Okay. So what about edge computing as it's becoming obviously bigger in IoT deployments? How do you think it will influence deployment strategies and also things like overall system architecture and even, devices that are low power? What can you tell us about that?
Yeah, yeah. So just like AI, edge computing is the buzzword of the day. But to clarify a little bit, edge, there are different edges, right? And edge computing means different things to different people. So edge pretty much means you are not in the cloud, but towards the enterprise or to the home side. And within that, also, there are different layers of edge, right? So you can be all the way to the edge near the sensor, which we call it sensor edge, which is the device edge, right? Where the IoT device is, that is the farthest edge that is out there from the cloud, right? And then you have a edge, which is a gateway that, or a access point that the device talks to. That's another edge. There are technologies that can be put into a gateway or an access point to enable some of the IoT functions. And then there is a edge server kind of a thing where you have slightly more compute available. You could do high-end vision, AI, and other elements, right? So within the edge also there are various levels. Uh, and there are different trade-offs, right, of technologies and requirements and performance solutions. So the one at the very edge, the benefit is you the device edge or the sensor edge is you get the lowest latency. You can do inference right there next to the sensor data. You don't need to send the data all the way to the gateway, to the edge server, to the cloud. So you save a lot of power. Uh, that's where we are focusing with the IoT device solution, where you want to sense the various data coming from the environmental sensors. Maybe it's temperature, pressure, humidity, or even it could be audio sensing, right? So some wake words or somebody crying or gunshots. You want to take action right there. If the vibration sensor is saying, hey, the vibration is going off limit, then you want to shut off the motor, shut off the device. So doing AI at the sensor edge is one of the capabilities or the trends you're seeing in edge computing. Then there are things happening at the edge server level, which is where you would have a little bit higher end robotics kind of vision AI happening. You may want to use slightly higher end chips like NVIDIA and others there. Uh, you want to make sure, depending on the device segment that you're playing with, you have the right level of AI, the right level of performance, right level of battery life uh, spec into the system architecture to make sure you have an optimal solution.
Okay. And now moving on to platforms to, manage everything that you're getting from your deployments. How critical is it to select the right platform for deployment and scalability of the IoT solutions, especially for large-scale developments?
Right. So as we were discussing, right, the IoT device solution has a lot of aspects. We talked about low battery or power. We talked about cloud connectivity. You have to be able to connect to AWS, Azure, like a certified solution available to start with. And then you need to have it secured platform with the right security features. So that's kind of the basic start with. And then we talked about upgradability. You want to make sure you can seamlessly upgrade the solution from deployment standpoint, lower ease of use, lower cost of operation standpoint. You want it to be scalable to the new features, new standards coming up like AI, like lossless audio, like Matter solution that can help interoperability even broader. And then you want to be able to make sure you are interoperating with the services level also. If you can add location services to your IoT device, you can add some surveillance service through the video or image capture. So getting the right platform is key, because it's not just getting one function done, deployed, and being okay, but you have to be making sure you can upgrade the platform, you can provision the platform easily, you can add some services down the road, add features and capabilities. So that's kind of the system level view you need to have, not just the day one, but the day two and the day n operation of the device also.
Okay. Well, what about interoperability? It can be a barrier to some IoT deployments. And I was wondering, do you maybe have something that you can share about how InnoPhase IoT approaches it, and maybe other companies looking at this challenge can learn something from that?
Sure, sure. So one of the things about interoperability is to make sure you pick the right technology, right? So as I said, you want to go wireless for ease of use. There are a lot of wireless technologies out there. There was BLE, there's Zigbee, there's Thread, there's Wi-Fi, there's cellular, right? So what you want to pick from an interoperability standpoint is the most predominant technology, and Wi-Fi stands out as the most predominant technology, right? So you have access point in pretty much every home. You have access point in all enterprises. Wi-Fi is there. It's going to be about 50% of all smart home devices will have Wi-Fi. So just by picking Wi-Fi as a capability in your device or technology would allow you to interoperate with the plethora of devices as well as the infrastructure that's out there. You want to make sure you have a BLE solution with it so that you can provision it well and you can interoperate with the legacy BLE devices, right? So that gives you a starting point. The other thing is cloud connectivity, right? So you want to be interoperable with the different public cloud solutions that are out there, like Azure, AWS, Tuya. You can have your own other favorite public cloud, or Google or other public clouds. InnoPhase IoT makes sure we have a software solution on top of our SoC and modules that allows you seamless interoperability. It's certified solution, right? And then the other key thing is, okay, even if you pick Wi-Fi, you have a Google Nest and you have an Apple Siri, and the interoperability is not there. Even if all of these devices are Wi-Fi, there is an ecosystem, Apple ecosystem, Google ecosystem, Amazon ecosystem. So what InnoPhase IoT does, along with other companies and the industry, they've said, okay, let's develop this Matter protocol, which allows interoperability between these various ecosystems, even if all of them are Wi-Fi. So Matter runs over Wi-Fi, Matter runs over Thread. So we've implemented Matter running over Wi-Fi so that our device can talk to pretty much all ecosystems that are out there, right? And that has been, like, I would say, multi-decade problem that consumer faces. Every device they buy, it's tied to this multinational firm, and it doesn't talk to nicely with other devices. So we've solved the problem through having Matter running on top of Wi-Fi. Matter doesn't run over Zigbee. Matter doesn't run over BLE. So again, picking Wi-Fi and running Matter over Wi-Fi allows you to have a good solution that is interoperable. So that those are some of the techniques that we use supporting the broader industry effort for interoperability.
Okay, great. Well, moving on, want to talk about regulatory compliance currently. As you see around the US, the EU, and the UK, a lot of regulation is coming in, at least regarding consumer IoT products. I was wondering if this kind of picks up pace and starts bleeding in to the more enterprise side. What considerations should businesses keep in mind regarding that, and even market adaptation?
Sure. So I would say regulatory requirements are more than considerations. They are like a hard table stake requirements, right? You have to pass the regulatory requirements, otherwise you can't ship the product in the country or the region, right? And so we've ensured that our devices, our chips, as well as modules are certified, FCC certified for the US, European certification, China, Korea, Australia, New Zealand, Japan, Telex. So all the regulatory certifications have to be done, test reports submitted, and then pretty much it's marked on the chip and the module that we are certified. The plus of it is, if you reuse our reference designs, which is the other requirement, which you say, hey, this is how you place the module, this is how you connect the antenna, this is, if you design it the way we are recommending or the way we've done in the reference, then you don't need to go through your own certification. You can say, hey, my device is pretty similar to InnoPhase IoT reference design, which you guys have already certified, so my device should be certified. So our customers save 6 to 9 months trying to go through their own certifications just by leveraging the certifications that we've already gotten through our reference designs and through our modules. So certification, as I said, it's a table stake. You have to have it, and then working with the right partner allows you to save R&D costs, save time, and enable quick time to market, right? The 6 to 9 months that I'm saying that we want to enable, having a certified solution upfront is a pretty much a basic necessity.
Okay. Now, I've been talking about, edge and AI, but I was wondering what other trends do you see shaping the IoT landscape maybe in the next 5 years? And just like with the regulatory compliance, what should companies be doing to embrace these new trends coming down the pipeline?
Sure. And actually, interestingly, I just recently had an article published with IoT Insider on some of the key trends. So I would encourage the audience to, if they get a chance to read that, that covers a lot of the trends happening. But some of the key trends, as I said, besides Matter protocol that's coming, which is going to enable ease of use of interoperability between various Wi-Fi devices, the trends of having AI not just in the cloud, which is well known, not just at the edge server, but all the way to the device edge and the sensor edge. And you need some compute in the device, which we integrate with our Wi-Fi solution, some SoC with MCU built in that allows you to do tiny ML models right at the sensor edge that will help you do predictive maintenance, audio sensing, even some person detect at a low resolution. You could do it to take some quick, low latency, low power inference solutions that would help you with the operation of your device. We are also seeing with Wi-Fi a lot of lossless audio streaming need happening. So in the past, you had your cell phone, and the cell phone would get the audio stream, and the cell phone will play to the speaker or to the headset through BLE. Of course, BLE is a great technology. We do support it also, but the BLE is a throughput constraint, right? It's 1 megabit, 2 megabit. So if you have truly lossless audio with encoders like FLAC, or if you want to do 192 kilohertz 24-bit samples, very very high end audio, you need the Wi-Fi throughput. So we are seeing from a throughput perspective, not just Wi-Fi required and Wi-Fi over audio over Wi-Fi, but also from a range perspective, Wi-Fi has a bigger range than BLE. So you can have a headsets which can directly stream from Spotify, or speakers directly streaming from Spotify or Tidal or some audio streaming service. And then you can move around in your home, again, wireless, low battery requirement, which enables you a different user experience for audio, right? You can have internet radio, you can have this audio streaming services enabled through Wi-Fi and low power Wi-Fi, paired with, again, with the right DSP chip with our silicon partners. This trend towards more and more security standards. I mentioned PSA, PSA2, PSA level 3, upgradability, ease of provisioning using BLE. So you can provision the Wi-Fi just using your cell phone BLE, which makes it very easy for a normal consumer. So those are some of the trends which are addressing the hurdles which were stopping the growth of IoT, but also enabling new features and capabilities that would extend the use of IoT in other segments like audio and smart home devices using Matter.
Okay. We've talked a lot about deployments as well as partners, platform partners who kind of aid companies in those deployments. I was maybe wanting to ask, what does a successful partnership between a solution provider and their client look like, and how can this relationship influence the success of an IoT rollout? You talked about, the availability of partners helping with interoperability, but I was wondering what else you could add to the mix.
Yeah, yeah. So the way we work with customers, as I had said, it's a complex subsystem. It's very different from one IoT device to another. So we actually, when we engage with a customer, we have a discussion about their use case, the requirements in terms of performance, ease of use, things like that. And based on that, we pick a reference design that makes sense, which would be the closest to their needs, which will allow them for the quick time to market with a reference design that is a hardware and software solution ready to go. Then we pair the customer. Sometimes the customers has a good engineering team with vast resources of hardware, software, OS, drivers, other capabilities. But sometimes the customers don't. Some customers are good with hardware but not with software. Some have cloud expertise but not the device level. So we have an extensive device design partner program where we have engineering companies that have the capabilities of hardware, software, and the cloud connectivity piece that they can take our reference design and customize it to the requirements of the customer, right? So the it supplements the resources that the customer has, but again gets a quick time to market. Some of these design partners already have worked with prior customers with our chip, our reference design, that allows them to move much faster with it. I mean, some of the software partners we have are more familiar with the latest technologies that we are developing, like Matter, AI, audio. So the software partners can also help the customers get their product out faster. So the journey with the customer is more of understanding the requirements, picking the right solutions that we have, platform level solutions, and then bridging the gap with the design partners, software partners, cloud partners to get the overall solution going. And that's kind of the mantra we are doing, and that has helped with very happy customers. So when they have the next project or there are other customers who look at it, then they come to us. We take a total ownership rather than saying, hey, this is an MCU problem or this is the AWS problem. We take the ownership to get the end-to-end solution working, debug any issues that come about, and work collectively as a team with silicon partners, with design partners, cloud partners, and some software partners to get the solution done in the quick time to market constraint.
Okay, well, I think that's a good place to end it. Deepal, thanks for taking time to speak to us today.
Yeah, thanks for the opportunity. It was a real pleasure to talk, and pretty excited at InnoPhase IoT to pave the way, be part of the leaders to drive the solutions that will enable the IoT market and drive the growth that everybody is looking for. So thank you very much. Really appreciate this.
IoT Unplugged. Tune in to the Internet of Things.